Hi, I'm going to talk about the topic batteries. At first, you should know about what is a batteries. Batteries is a device. It's a consisting of a series of electrochemical series attached in a series manner. So the device it consists of electrochemical series arranged in a series manner. A several electrochemical cell. So several electrochemical cell connected in a series manner. So getting a batteries. So before that, you should know about the what is an electrochemical cell. So electrochemical cell is a device in which it can convert the chemical energy into electrical energy. A process of conversion of chemical energy into electrical energy. Chemical energy into electrical energy. So next one, I can briefly explain the what is electrochemical cell. So I can construct the electrochemical cell such as it's consisting of two op cell. The one op cell it can act as a anode. Then one op cells. So op cells that means consisting of a anode and corresponding it can dip it in its own salt solution. For example, I can take as a zinc. So in this op cell, zinc act as a anode. So it can dip it in its own salt solutions like a zinc sulfate. Is one of the op cells. So electrochemical cells we can connect one more op cells. So this can act as a anode. So it is called anode compartment. This is another op cell. Example copper. So in its a copper deep its own salt solution copper sulfate. So these are the two op cells connected by a external circuit via voltmeter. So this can be get complete by we can connect it towards a one more salt bridge. The purpose of salt bridge to can maintain the electrical neutrality between the two op cells. So example can use as a KCl for that. Then complete electrochemical cells. So in this offside, it is called AND compartment. The second half is a cathode compartment. So anode compartment, it takes place the reaction is called as an oxidation. In cathode compartment, the reaction takes place as a reaction. So the process complete is called redox type of reaction. So getting the redox reaction take place in an electrochemical cell. That means the both reduction and oxidation in a chemical reaction take place simultaneously. As a result of these redox reactions, what happen? EMF can be produced by moving of electron from anode compartment to cathode compartment. The electron transfer between anode compartment to cathode compartments. It can show a voltage in a voltmeter. So it is called as an EMF. So EMF will be produced as a result of a complete cell reaction. That is electromotive force. EMF means what? The difference in the electrode potential as caused during the reaction of a redox reactions, which shows the EMF. So this complete concept can works under the thermodynamic principle. So what is that? This complete concept works under the thermodynamic concept. The famous principle that is called decrease in free energy. So any chemical reverse reactions, this can show a decrease in a free energy. This free energy corresponds to producing EMF. So it shows del G is equal to N F E. This is a reaction. It's a concept of thermodynamic principles. So works under the concept of electrochemical cell. So you know very well del G is a decrease in free energy. So in a chemical reaction, it shows some decrease in free energy. It corresponds to the producing the EMF by a number of electrons transfer from anode side to cathode side. It can correspond to 1 Faraday. So it is called as a decrease in free energy gives to minus NFE. This concept of a thermodynamic principles works on every electrochemical cells. Now discuss about the different types of batteries. Can classified three types of batteries. The first one, primary battery, and second one, secondary, and third one, flow battery. So these are the three different types of batteries. So all the batteries, the same concept of a electrochemical cell. Some of batteries can be reversed, some of batteries cannot be reversed. So based on that, can taking a what type of anode and cathode present in an electrochemical cell. For example, primary batteries. The primary batteries is one kind of a irreversible battery. So just means that electrode and electrode reactions cannot be reversed. So it is called as an irreversible batteries. It is also known as non-rechargeable batteries. Non-rechargeable batteries. So what does it mean? That in which the both cell reactions, both anodic or cathodic, cannot be reversed. So it is called as a non-rechargeable batteries. I give some example for that. Example, dry cell. And second one, one more example, alkaline battery. These batteries are considered as a non-rechargeable batteries because the cell reaction cannot be reversed by causing an external electric current. Next type of battery, it is a secondary battery. So what does mean that secondary batteries also known as reversible type of batteries. So reaction can be easily reversed. It's an reversible batteries. Is also known as rechargeable battery. So in which, just like same, primary batteries cannot be reversed, but in the secondary batteries it can be reversed. Both electrode and electrode reactions can be reversed when by causing an external electric current. So the batteries and reaction can be easily reversed. So this can be used for charging and discharging purpose in regular batteries. Give some example for that. The first lead acid batteries. So very well known lead acid accumulators. So it is called lead acid batteries. The one type of a rechargeable batteries. And second one, nickel cadmium batteries. This is also a one type of a secondary batteries. This can be rechargeable one. And third one, lithium batteries. This one commonly mostly used in all mobile phones. Then third one, flow battery. So in this call example, I give example for that. H2O2 fuel batteries is commonly called as a fuel cell. What's a fuel cell? In which the reaction can be proceed at instantaneously. So what is that? For example, the hydrogen is act as a fuel for that. So hydrogen can be act as a fuel. It can be easily oxidized in presence of oxygen, can easily gives to the some oxidized product and giving some electrical energy. So this is a flow battery example, very good example, H2O2 fuel cell. Then we discuss in detail about all the batteries. Primary batteries, example, dry cell alkaline battery. Secondary battery is also one kind of a rechargeable batteries, example, lead acid battery, nickel cadmium and lithium batteries. And third one, flow batteries, also known as fuel cell, example, H2O2 fuel cells, mostly widely used in a aircraft. We discuss some examples about the primary batteries, secondary and flow batteries. So at first we discuss about the primary batteries. We'll discuss about the topic of alkaline battery. The more commonly used batteries in nowadays. Previously, we can using a dry cell. So dry cell, we can using a ammonium chloride as a electrolyte. But I can replace ammonium chloride by some components, especially we can using KOH. So KOH is a well used in alkaline batteries as an electrolyte. Because when compared to dry cell and alkaline battery, so alkaline batteries are long shelf life when compared to dry cells, and having a some leakage will be happen dry cells. So we can replace the dry cell by the alkaline batteries. So alkaline batteries is a very good example for the primary batteries. I draw the picture of the alkaline batteries. Positive terminal is a negative terminal. It's consisting of zinc body. Zinc body connect as a anode. The anode side, the zinc cover. This is a cathode. So you can fill the electrolyte of MnO2 make it a paste form by using starch. Paste of MnO2. For the example, starch and small amount of your water. Listen, a carbon or graphite can take in. This act as a inert type of electrons. So this can be which can conduct only the electrons. So I have description about that. Containing anode as zinc and cathode graphite. Electrolyte a paste MnO2 starch zinc and small amount of graphite. We can using a paste form in an electrolyte. Okay. Next one, discuss about the reactions will take place in a, this kind of cell. The first one, anode reaction. So you'll know that anode compartment having a zinc. So zinc get oxidized. So anode reaction, what is the reaction? Oxidation will take place at the anode compartment. So the anode reaction is always takes oxidation. So what is oxidation? Oxidation means what? The loss of electron. These are called oxidations and gain of electron is called reductions. So zinc get oxidized by loss of electrons to form zinc 2 plus release of 2 electrons. So after the zinc 2 plus ion disposed into electrolyte, it's consisting of a KOH. 2 plus can react with minus to form zinc hydroxide. So overall reaction zinc to form hydroxide with release of 2 electrons. These are not reactions. Just like the cathode reaction, it's a process called reduction. The cathode consisting of MnO2. It's made into paste with a water molecule. H2. It gains 2 electrons which can releases from the anode compartment. So this takes 2 electron from the anode side. So electron transfer from anode to cathode. Form a corresponding product of Mn2O3. To balance, isn't the product get from the during the process of a reduction. So I can write the overall cell reaction. Overall cell reaction gives the left hand side of a anode compartment. Zinc 2 MnO2 plus H2. It gives a product of a zinc hydroxide Mn2O3 is an overall cell reaction of a alkaline battery. So as a result of this reaction, producing the EMF of a 1.5 voltage across the circuit. So when the reaction will proceed, it producing the constant EMF of a 1.5 voltages. Isn't I told previously, alkaline batteries are better than the dry cell batteries because it is a very good leakage proof and also having a long shelf life when compared to the dry cells. And one more, it's mostly widely used in some torches, calculators, watches, something, etc. Now discuss about the second one and I'm going to example of a secondary batteries. Secondary battery is also an example of a electrochemical cell. It's one kind of electrochemical cell. So in this cell, this can be useful for both discharging and charging purpose. In charging purpose, these batteries can act as a electrolytic cell. During discharging process, the cell can act as a electrochemical cell. So both cell can be actors because it is a reversible cell. So in forward reaction, it can proceed the discharging. Backward reaction can proceed the charging. So in both process, it can act as a electrochemical cell and forward process, electrolytical cell in a backward process. So because it is one kind of a reversible cell. So same way, it can convert the chemical energy into electrical energy, vice versa. So during charging, what happens? Electrochemical cell will behave as a electrolytical cell. So during charging, so what happened during charging? By applying a external electric force, that means when applying electric current towards the cell, it happened in a charging. So during this process, electrical energy produces the chemicals. That means is convert the electrical energy into chemical energy during the process of a charging. So during discharging, so the reaction can be get reversed. So what happens? The chemical energy get reversed. The chemical energy converted into electrical energy. So this process, it can act as a electrolytic cell. So in this process, it can act as a electrochemical cell. So clear. So both charging and discharging take place in all secondary batteries because it can act as a reversible cell. So all the electrode and electrode reaction get be reversed. So when reversed means by applying electric current towards itself. So what happens? The reaction can be reversed. So the oxidized product can be get reversed. So getting a some electrical energy in the electrochemical cell by consume of electrical energy, it can convert the reverse the content in the cell. We discuss in detail. For example, attacking the lead acid battery. Example, very good example. Lead acid batteries. You can draw the working cell diagram. And I draw the black diagram of a secondary batteries. Taken container of a polypropylene container because we can using a acid. The electrodes can immerse a pair of electrodes. One is an anode and one is a cathode. So I can take in a series of a ion electrode can connected in a series. Taking three sets of electrodes. This can be separated by some insulators. This is an anode, this is a cathode. So I take in a three set of a anode and cathode connected in a series manner. This is an anode compartment. I marked as a negative. This one cathode connected in a series manner. I put as a positive terminal. By connecting this negative and positive through a circuit, we are getting a complete closing of circuits with the voltmeters. We can signify some volt changes in the during the chemical reactions. So all the electrodes and cathodes dipped in a acid solution. So this can act as a electrolyte in the reactions. So I can take in a sulfuric acid H2SO4. Exactly I take a 38% and whose specific gravity is nearly about a 1.3. So gram per ml. So specific gravity. I take in H2SO4 as an electrolyte. 38% of sulfuric acids and whose specific gravity should be 1.3 gram per ml. So description about this lead battery. So we can take in as anode as an lead, cathode as an lead oxide, then electrolyte sulfuric acid. This is a component of these lead acid batteries. So anode and cathode deeper in the sulfuric acids. This will be cycle will get completed. They connected through the external circuit via voltmeters. Now did explain the what cell reaction take place in this lead acid battery. So discuss about the cell reaction. So the anode compartments, we will know about that the oxidation will take place at a anode compartments. So oxidation at anode side, anode oxidation. What is the compound like an anode? Lead. The lead get oxidized. So what happened? The lead oxidized product of a lead 2 plus by releasing of 2 electron. So upon oxidation, what happen? It loses the electrons. So lead loses 2 electron to form corresponding cations to form lead 2 plus. The lead 2 plus enter into a electrolyte solutions containing H2SO4. So after that, the lead can discharges the 2 electron to form lead 2 plus entering into the electrolytes. So what is containing electrolytes? Consisting of a H plus SO4 2 minus. So the lead 2 plus react with sulfate present in electrolytes to form a corresponding products, just like the same. The lead entering into the electrolyte solution of a sulfate. So it can react with the lead with the sulfate to form a lead sulfate. Is a product of a anode compartment. So the overall on reaction, lead react with sulfate to form lead sulfate, the release of 2 electrons. So after discharging, the 2 electrons goes to anode to cathode compartment through a voltmeter. So in crossing the electrons from anode to cathodes, that means what? The flow of electron from a anode side to cathode side, that is called producing electricity, producing a charge carriers. So electron flow from anode to cathode. So after entering the electrons anode to cathodes, what is the cathode containing? Cathode containing a lead oxide. The lead oxide absorbing the 2 electron from the anode compartments. It doing a reduction reactions. So in cathode side, it shows a reduction reaction. So the reduction means it can gain electron from the anode side. It's consisting of a lead oxide. The lead oxide carries a 2 electrons from the anode compartments. Is also deeper in a sulfate solution. The presence of H plus ion and sulfate ion as a electrolyte. So the reactions take place in these conditions. The lead oxide carries a 2 electron in presence of acidic medium. So what they get is the same component, lead sulfate. The product will be obtained as a result of a cathode reaction. So the lead oxide react with the presence of carrying the 2 electrons from the anode side, and in presence of acidic medium, it convert into lead sulfates. So in anode reactions also get the product of a lead sulfate, same as the cathode reactions get a lead sulfate. So we're getting a 2 lead sulfate here, this one. The same product will be obtained as a result of both anode and cathode compartments. So overall reaction, it gives overall cell reaction. So what is that? Lead, then here lead oxide and 2 sulfuric acid. It gives a product of a 2 lead sulfate and giving a water molecule. these are reactions get during the reaction of a discharging. So for during discharging, it can act as a electrochemical cell. So in this cell, it will producing electrical energy during the discharging process. So as a result of this reaction, we getting an EMF of a 2 voltage, 2 voltage per cell. Per cell, it produces 2 voltages. We connected in a series 2 plus 2 plus 2 plus, we can get a 6 voltage of this battery. So whatever need, we can connect a number of anodes and cathodes in the series to getting the requirement of our voltages. So in this a single chemical electrochemical reactions getting the EMF of a 2 voltages. So after that the process will be complete, we can get the charging process. So what is charging process? The charging process can reverse the reaction. The same we get reverse. So forward, I said before, the forward reaction is called as a charging. Sorry, discharging. And backward reaction is called as a charging process. So after the reaction will be completed, so after the electrode will be exhausted, we need to charging the batteries. So during the charging, what happen? The lead sulfate get it producing the corresponding lead and lead oxides. At the same time, the water molecule it can convert into corresponding acids. This is a process of a charging. So in this case, all the discharging and charging will be doing, because it is a reversible cell. I give some advantages for this. So what is that? Is widely used in several automobiles, car, buses, lorries, etc. So because basically you can using several advantages by using, because it's a kind of reversible batteries. So you can using hospitals also. But some disadvantages. What is that? Disadvantage means what? Takes a heavy weight. It's weight, and it can be discharging. The waste will be containing a lead and sulfuric acid. These are not both are not eco-friendly in way. So it is the mainly disadvantages from that. During disposal of this container is consisting of a lead and sulfuric acid act as a non-eco-friendly manner, so can creating a pollute to the environments. So next we move on to the next type of battery, flow battery. The next type, flow batteries. Example, H2O2 fuel cell. Why it is called fuel cell means you can using a hydrogen as a fuel for this process, but there is no combustion take place in this process, because it can be, in these cases we can do not combustion. So without combustions, electricity can produces by the reaction of a redox process. The same concept of, as we discussed, secondary batteries can also occur in a flow battery also, can doing a redox reactions. So in this case, for example, one kind of fuel, it oxidized in presence of oxygen, giving the oxidized product and giving energy also. It's a common reaction of a flow battery. The fuel can be get oxidized presence of oxygen, giving a oxidized product and giving energy. The energy means we can getting electrical energy, producing the electrical energy. Some major advantages of this battery can producing the instantaneous battery. So instant, but is also known as instant battery, getting a more number of voltages during this process. So this mostly widely used in several military appliances, and for can also act as a rocket fuels, secure because giving a very instant energy at very fast. For example, I take a hydrogen. It producing the product of a water and giving a voltage about 0.8 to 1 volt of a electricity during the single cell reactions. So hydrogen get oxidized in presence of oxygen to getting a corresponding water molecule, getting water vapor. As a product. We discuss in detail about the H2O2 fuel cell. I draw the cell diagram. We separate into anode compartment and cathode compartment. I consider it as an anode compartment, it is a cathode compartment. In porous carbon electrode, in both anode and cathode can taken as a inert graph. We can take in graphite or carbon. It should be a porous electrode. This can be connected to the cathode by a external circuit. Here hydrogen can bubble. So on this side can bubble the oxygen. Getting a product of a water in this way. KOH is an electrolyte. This is an actual block diagram of a H2O2 fuel cell. So what's the requirement? What is the anode? Anode is an carbon. And cathode is also a carbon. So both should be taken as in porous type of a carbon electrodes. So in which can, so the ions can be easily dispersed through the electrolyte. So after the reaction will open, so what happens during the displaced ions can move through the electrolytes through a porous electrode. So we can using a porous type of a carbon electrode in this process. Electrolyte you can take as an KOH, potassium hydroxide electrolyte. Is a requirement. So anode and cathodes both can act used as a porous type of a carbon electrodes. So in this electrolyte you can using KOH. So when working, the hydrogen can bubble through the ion compartments. Same way the oxygen can bubble through the cathode compartments. So in which the reaction will take place. Anode side it take place the oxidation. What is that? We can bubbling the hydrogen to the anode side. It can be oxidized. Hydrogen can be oxidized to form a 2H plus and release the 2 electrons. So it releases the 2 electrons during the upon oxidations. So the 2H plus ions dispersed through the disporus. Dispersed through the disporus. So electrons move towards this manner to the anode to cathode. The electron flow. So after the reaction will over, the dispersed H plus ions moves toward the electrolyte having a OH minus ion. This H plus ion react with this OH minus ion to form a corresponding water molecule will be formed. So 2H plus goes to electrolyte containing OH minus to form 2H2O. Is a cell reaction take place at a anode compartment. The overall reaction will give a H2 plus 2OH minus to form 2H2O and giving it 2 electrons. Is an overall cell reaction take place at a anode sites. So in cathode side having a oxygen can be bubbled. So oxygen, a single oxygen carries the 2 electrons. So we need 2 more electrons. So I can double the reaction. It's because a single oxygens it carries a 2 electrons. We have O2, so it can have 1 more oxygen. So each and single oxygens can react with 2 electrons. So consumes a one more pair of electrons. So I can double this reaction. I multiply by this 2 in this reaction to getting 2H2 plus 4OH minus gives 4H2O, then 4 electrons. So you can double the reactions. As a cathode, it take place reductions. What is a cathode? We can bubbling the oxygens toward this compartment. So oxygen carries the 4 electrons from the anode. It gives a product of a 4OH minus. Taking product from the cathode side. So oxygen get reduced by absorbing these 4 electrons having a 2H2O molecules, having a water molecules. So getting product of a 4OH as a product. So you can write the overall reaction for the flow battery. Overall cell reaction. So you can write 2H2 O2 gives 2H2O plus EMF of a 0.8 to 1.0 volts. So as a result of these reactions, the hydrogen get reduced to getting a product of a water molecules, getting energy about the 0.8 to 1 voltages. That's an EMF of a this cell reaction. So the EMF maximum is 0.8 to 1 voltage for a single cell reactions. So that's giving a only a product of a water molecules. These water molecule can be used for a astronauts in a space. So here there's no more pollutants will be produces during the cell reactions. So this is a completely a pollution-free reactions. I'll give you some advantages for that. So in these cell reactions, I will told before, it can mostly widely used in several military equipments, submarines and aircraft, missiles, etc. This is mostly widely used in a military purpose and a aircraft or space shuttles usefully. So next one, And also they can producing a product of a water molecule. This water molecule can consumed by the astronauts. Some advantages. Then pollution free, eco friendly, etc. So having some disadvantages. What is that? So in this case, can using H2 as a fuel. So H2 is a very difficulty stored and can maintaining under this pressure condition. So care should be taken during the usage of this hydrogen, because hydrogen is a very purest gaseous substance. So care should be taken during the utilizing this fuel. And H2 is an expensive fuel also. So these are about the flow batteries. So example H2O2 fuel cell. So in this case, fuel get oxidized to getting product of a oxidized product and getting energy. The energy will be getting the form of electrical energy. So a very good example is H2O2 fuel cells. H2, the hydrogen get oxidized to form a product of a H2O by producing the EMF of a 0.8 to 1 voltages. So the cell diagram about that, we can in this left hand side is considered as a anode, right hand is considered as a cathode. Left hand side the hydrogen can be bubbled, and the right hand side oxygen can be bubbled at the cathode compartment. So during the cell reactions, the hydrogen get oxidized to getting a to electrons. Electrons moves towards anode to cathode via external circuit. The electrons consumed by the cathode is consisting of a oxygen. So oxygen get reduced in presence of electron to get a product of a two water molecules, which are releasing of hydroxyl ions. So you can balance the hydroxyl ions. So all reactions can producing the EMF of a 0.8 to 1 voltages. So next move on to the topic. Solar energy conversions. Our next topic discuss on solar energy. So well known about the solar. So the solar sources, the main source of solar energy is the sun. Sun is a major source of a solar energy. So getting some radiations from the sun. You know well known it is an IR radiation. This radiation can be utilized by some process IR and also receive the visible light. These are the major component in a source of sun. IR radiation is responsible for a heat signature. The light is absorbed for a light. The heat can feeling heat from the sun. So what is the main source because of having higher radiations? Then we can seeing the objects with the help of a light source. So that is invisible light. So these are the major component of a sun. By utilizing these two components, can performing a some energy conversion. So what is that? The majorly can convert the two main conversion. The one is photo conversion. So one more, it is a thermal conversion. What is the photo conversions? The photo conversion means what? The photo means what? Light source. So we can convert the light source into corresponding energy. So in this photo conversion process, the light from a sun, the light energy convert into electrical energy. This is an example of a photo conversions. A very good example, solar cell. Yeah, well known about the solar cell. So the solar cell receiving the light source from the sun and converts into corresponding electrical energy in this process. So it is called photo conversion. What is thermal conversion? So in the thermal conversion means what? Heat. The heat source from the sunlight, it convert into a corresponding energy, different forms of energy. Thermal means what? Heat. The heat from IR source. The heat from IR source, it converts into different forms of energy. It converts into different forms of energy. So then both cases it can utilizing the a source of a sun. So the first case, the photo conversions, it means it can carry the light energy to convert the electrical energy. It's the most oftenly widely used process. The thermal conversions, you can get collect only heat from the sources, the heat from the sun, and convert into different forms of energy. This is majorly used in a cold places. What are the examples? You can using a solar heat collectors. So in cold places, the heat collectors can collect these IR sources and warm the entry places. So mostly in houses, we can inbuild the solar heat collectors. The collectors can absorbing the heat from the IR sources and can heat up the entire houses. So this is mostly widely used in the cold countries. And we also can using a solar water heater also. So these are two main examples we can utilizing the thermal conversions from the heat from the IR source. This can utilizing the light source from the sun to convert the corresponding electrical energy. We'll discuss in detail. Very good example, solar cell. In this case, first we know about what is the principle behind the solar cell. It works on a principle of a photovoltaic effect. So we refer as an PV effect. So photovoltaic effects. It means what? A light source from the sun incident on any material. A light source from the sun incident on a material can eject some electrons, some conducting electrons. So these electrons can move in a circuit to get converted into electric current. The process of it is a concept of a photovoltaic effects. The light source from the sun can eject electrons from the materials. Eject electrons can be moved towards the external circuit. It can be produce electric current. This is the concept of a photovoltaic effect. So based on the principle of photovoltaic effect, we can construct the solar cell. We can draw a solar cell representation. then P type, then N type. So we need to construct a solar cell with utilizing the semiconductors. So we can taking a two semiconductors, N type semiconductor and a P type semiconductors. So what is N type semiconductors? The N type semiconductors having a rich in electrons, just like that. In P type semiconductors having a more number of holes. This signifies positive. Just like that. So at first we can combine the N type semiconductor and P type semiconductors at first. So during combination can create a PN junction. So without any external energy, so what happens? Just you can fuse the N type and P type semiconductors. What happens? It creates a NP junction. So it called as an PN junction. At first it creates the PN junction. Because in this case the positive moves towards the crosses the PN junction and reaches the N type. At same time the electrons from N type move towards the P type, creates some double layer just like that. It creates a positive and negative on a P side. So this can be further prevent the movement of electrons towards the P type and positive holes towards the N types. This can be prevent the movement of a electron and positive holes towards these sides. So this will be happen without doing any external field. So now we can allowing the sunlight. Now we can expose to sunlight. So what happen? The sunlight reaches the PN junction. So the PN junction, it can create the positive, negative hole pair, just like that. Creates the positive, negative hole pair. So you know well that the sunlight having an energy of a photon is equal to h nu. So after it reaches the PN junction, the energy of a h nu, it can dissociate this hole pair. It dissociates the hole pair as a positive and a negative. So the negative electrons drifts over the N side and positive hole drifts over the P sides. Create a more concentration on this N side and P sides. So this more concentration of electrons can move toward the circuit by connection of a external circuit. Connecting voltmeter, some light source. It shows the drift over the electrons. So the electrons from the conduction band and ejects into the concentration on a n side and a holes on a p sides. So electrons moves from n side to p side. The flow of electrons well known though that electricity. So electron flow from n side to p side. So those are the same conditions. The opposite sides what happen? The current will be flow from a p sides to n sides. So the light can be glowed. This is the concept of a photovoltaic effect. So n-type semiconductor and p-type semiconductor can be fused together and it forms the p-n junctions. So when exposed to the sunlight entering the p-n junction and dissociate into this whole pair into positive and negative. This negative electrons moves towards the n side and positive moves toward the p side. Create some concentration of electrons in a n side and a more number of holes on a positive side. The drift over which can cause the electrons flow from a n type to p side. So it can glow as a light, can produce electricity. So this is a concept of a photovoltaic effect. This is mostly widely used in several fields. In agriculture, you can using a water irrigation pump. You can utilize this energy can circulate in the pump also. And next we can use as a some street light and some other purposes mostly and are also widely used in several space shuttles also. So thank you.